Hello everyone, welcome to IIT and GATE classes. This is lecture 1 on operating system, and in this lecture we are going to discuss about syllabus of operating system, and I will try to cover few topics of your first chapter, that is introduction to OS. Okay. So coming to the syllabus, we have four chapters in operating system. First chapter is introduction to OS, second is process management, third is main memory management, and the fourth is secondary memory management. So let me discuss the syllabus of all these four chapters one by one. First is introduction to OS. Okay, so in this we have four topics: definition of operating system, then interrupt trap signal, then protection, and then types of operating system. This is first chapter. Second is process management, and I think you have guessed it right that this is one of the biggest chapter of operating system. So in this, we will study first is introduction to process. Okay, so what is process and so on. We will study all these things. So you may think that program under execution is process and so on, but actually process has lots and lots of extra things. We will study that in the introduction to process. Second will be CPU scheduling algorithms, like you have studied first come first serve. Okay, shortest job first, longest job first, and so on. Okay, round robin. You have studied. You have heard all of them. If you have not studied, then at least you have heard the names of these algorithms, and we will cover them in detail. Next is process creation, that is how process is created. So process is created using fork system call. Okay, we will study this fork system call and so on. Next is inter-process communication. Okay, so inter-process communication, there are many ways of inter-process communication, like message passing and so on. We will study all of them. Next is producer consumer problem. Okay, we will study it. Then critical section problem. So critical section problem, there are many solutions to critical section problem. One of the solution is OS based solution, and that is your semaphore and so on. You have heard about semaphores, etc. We will study them in detail. Next is classical problem of operating system. Like I have already given you idea of producer consumer problem. That is one of the classical problem, and others are lining philosopher problem. Okay, sleeping barber problem and so on. We will study all these, and then deadlock handling will come, and then threads. Threads is a small topic. We will cover that also. Okay, this is all about process management. Next is memory management. So in memory management, we will cover three topics. One is contiguous memory allocation. A contiguous memory allocation is MFT, MVT. MFT is multi-programming with fixed number of tasks. MVT is multi-programming with variable number of tasks. Okay, that is contiguous memory allocation. Non-contiguous memory allocation is paging and segmentation. Okay, we will study these two topics, and then in the last we will study demand paging. So these are the three topics in memory management. You may think that it is a very small chapter, but actually it is one of the big chapter also. Like process management, memory management is also a very big chapter. Okay, don't worry, when we will dig deep into it, you will get the idea. There are many subtopics in all these things. Okay, demand paging, there are many things. Okay, like page replacement algorithms, LRU, FIFO. Okay, you have heard about them and so on. You will study them. Paging is also a very big topic and so on. Okay, next is secondary memory management. That is the fourth chapter. That is introduction to hard disk. Okay, I will give you basic introduction how hard disk is designed and so on. Okay, hard disk consists of a platter and multiple disks and so on. We will study these. Okay, next it will be disk scheduling algorithms. These are very important. Shortest seek time first and so on. Okay, we will study these algorithms also. Many times question have been asked from this. Okay. Yes, first come first serve, shortest seek time first, and so on. We will study them. Don't worry. Okay, so these are the total four chapters, and I have discussed the syllabus also. Now I am going to start your first chapter, that is, see this, introduction to OS, and the very first topic is definition of OS. Okay, so I am going to start first chapter in detail, and first chapter, first topic we are going to study, that is definition of OS. Okay. So what exactly is operating system? So you, in different books you will find different definition, but the definition which I like the most is from your Galvin book. Okay, let me give you the idea. We will study operating system from Galvin. This is one of the best book for operating system. Okay, yes, most of the topics will be covered from this book only. So this book is saying a very good definition of OS. That is, it says that we have two views of operating system. We have two views according to which we can define the operating system. First is user view. First is user view. And the second is system view. User view and system view. Okay. So what is user view? User view means what are the expectations of user from operating system? What are the expectation of user from operating system? That means the user means the one who is using the operating system, like we are using operating system and so on. So what are our expectation? Indirectly, directly, I'm saying this. What are our expectation from operating system? Second is system view. System view is what are the expectation of, you may think that what are the expectation of system? System means what? Hardware. So actually hardware cannot expect something. Hardware is just like a machine, nah? It cannot expect. So expectation of uh, hardware, or you can say expectation of designer of OS. Okay. Designer of OS, and from which point of view? From system point of view. Expectation of designer of OS from system point of view. System point of view, or you can say hardware point of view. Okay. So there are two views which explain the definition of operating system. First is user view. What is the expectation of user? Second is system view. That means expectation of designer of OS from system point of view or from hardware point of view. So what are the expectation of user? So you being user, what are your expectation? Please let me know what are your expectation. So our expectation is ease of use. Ease of use. Ease of use means what? We want that everything should be done by operating system automatically. We should not interfere in the things like, for example, if I say, imagine a scenario where you have, if you want to create a file in hard disk, you have to write a program in assembly language, which will allocate space in hard disk. You have to write for each and everything, you have to write a program. Imagine that situation. So that is a very, very tough situation, and it will be almost next to impossible for you to, you can say, uh, to do task on your computer system. Okay, so obviously it will be very difficult for us. Okay, yes. So basically, what we want ease of use. Okay, that means everything should be done automatically. Like you create a file should be created automatically. We need not write a program for doing this and so on. We want to connect any device, then it should automatically, computer should automatically detect that device, and you should be able to automatically, you can say, uh, operate that device and so on. Okay, like you join a joystick with your computer system and you want to play a game, then obviously your computer system should detect it automatically, and you should be able to, you can say, play the game with joystick. Otherwise, you will have to write a program for each and everything in assembly language. That will be really very difficult for us. So our expectation is ease of use. That means your operating system must provide a virtual machine to us. Okay, the keyword is operating system must provide a virtual machine to us, which is very easy to operate. It must provide a virtual machine to us. Virtual machine in the sense like everything is done automatically. Okay, we do not need to do anything explicitly and so on. Everything is done automatically. That means this is a kind of virtual machine. Okay, so computer should act like a virtual machine in which virtually everything is done automatically. That's it. Okay, next is system view. So what are the expectation of designer of operating system? So what are their expectations? So they want that everything should be done in efficient manner. Okay, so system view is the keyword is it should OS should act like a resource manager. OS should act like a resource manager. So what do you mean by resource manager? That means it should be able to manage all the resources of computer system. So resource manager means it should be able to manage all the resources of operating system, all the resources of computer system. Manage all resources of computer system. Okay, in order to achieve maximum efficiency. So we want efficiency also. That means operating system should be very fast. That's all. Okay, so manage all resources of computer system to get maximum efficiency. To get maximum efficiency. Okay, so keyword for your user view is virtual machine. Keyword for your system view is resource manager. Okay, so we have used the term manage all the resources of computer system. What are the resources and how OS will manage them? We will study that in the next slide. Please note it down carefully. I'm jumping to next slide. Okay, so resources in computer system. Resources in computer system. So what are the resources? The very first and the very important resource is CPU. Then is your main memory. Okay, then is your secondary memory, that is your hard disk. Generally secondary memory is hard disk, and you can consider that as your see, whatever you are uh, whatever memory you are attaching with the computer externally, that is generally secondary memory, like flash memory. Flash memory is your pen drives, okay, like CD, DVD, and so on. Whatever we are using, these all are secondary memory. Okay, and the last is IO devices. Okay, IO devices like keyboard, monitor, and so on. That is also managed by your OS. So these are the resources in your computer system. So first resource is CPU. So how CPU is managed by your OS? Okay, what can we say in one word? See, CPU is only one, and there are many tasks which have to be executed. Okay, so CPU is only one. Okay, let me jump to the next slide, and in that slide I will show you how OS will manage CPU and so on. Okay, see, CPU is only one, and there are lots of processes in main memory like P1, P2, P3, P4, P5, P6. So directly I'm saying six processes are in main memory and CPU is only one. So which process will be executed by CPU? Okay, or you can say that CPU is executing P1. Example, CPU is executing P1. Now, which after execution of P1, let us assume P1 is completed. After execution of P1, which process will be executed next? Is it P2, P3, P4, P5, P6, and so on? Which process will be executed next? Okay, that decision is taken by operating system, and this is known as process scheduling. So process scheduling is done by operating system. Process scheduling is done by operating system. And OS should manage CPU in such a way that CPU should never be idle. CPU should never be idle. If CPU remain idle, then obviously, I think you have guessed it, that the efficiency will decrease, and you will think that your computer system is working really very slow. Okay, because your CPU is idle, and nothing is going to be happen and so on. So you may think that your system has hanged and so on. So this is the duty of operating system, that CPU should never remains idle. Okay? It should never remain idle. Okay. So that's it. So next resource is main memory. Okay. Yes, and let me tell you one brief idea that see, multiple processes are present in main memory na. So this type of operating system is known as multi-processing operating system. Okay? Or you can say uh, let me say it roughly, multitasking operating system. Okay, multitasking. So in today's world, multitasking operating systems are there na. So multitasking, it does not mean that we are running multiple tasks parallelly. It is not like that. Okay, real parallelism will occur only when we have multiple CPUs. If you have only one CPU, then only one task can be executed at a time. For example, you have one brain. You may think that you are doing multitasking, but actually you are doing one task at a time only. Parallelly means interleaved fashion, like uh, uh, P1 is not yet completed and still P2 will start, and then again P3 will start, and so on. So at a point, at a single instant, CPU is doing only one task. Okay, but now since technology is improving day by day, we have multi-core processors and so on. So in that cases, we can think that multiple tasks are executed parallelly. Okay, if you have only single core CPU, then we cannot think that multiple tasks are executing and so on. Okay, actually, only one task is going to be executed at a time because CPU is one. But anyhow, in mobile phone also we are getting octa-core processors and so on, hexa-core, octa-core, and so on. So octa-core means 8 cores are there. So directly and indirectly we can think that CPU can do 8 tasks parallelly. Okay, that is the basic way. Okay, don't worry about them. I have just given you a small hint of all these things. We will jump to this topic, types of OS. In that topic, I will give you pretty much detail of all these things. Okay. So yeah, this was CPU. You can say first resource was CPU. Next is main memory. Next resource is main memory. So how OS will manage main memory? See, main memory is limited. So we can have multiple processes. So as soon as process is created, it is present in hard disk. it will not immediately come to RAM. Okay, whenever a process is created, it is present in hard disk. Okay, and the area is known as job pool. Okay, in job pool, multiple processes are there, and time to time, some processes will come from hard disk to RAM and they will be executed and so on. Now, which process will come from hard disk to RAM? This decision is also taken by operating system, and this is known as job scheduling. Okay, so job scheduling is also done by your operating system. Job scheduling means decision about which processes will come from hard disk to RAM. Okay, RAM is limited. Now, main memory is what? RAM, random access memory, that is limited. And process, there may be many processes. So, which process will come from hard disk to RAM? That decision is taken by operating system. Main memory is limited. Now, we cannot have infinite main memory. Okay, so but hard disk we have compared to RAM, hard disk has much more capacity. Like for example, your main memory may be 4 GB and you may have hard disk for 1 TB. Okay, so that's it. So I think I have explained the point. So main memory management means roughly you can say job scheduling. Okay, so main memory is limited and multiple jobs are in hard disk. So which job will come from a hard disk to RAM? That decision is taken by operating system, which is known as job scheduling. Okay. So now you may argue with me, sir, why we need job scheduling? So we can take any of the job, and we can take I think I want to say that uh, randomly we can pick up the jobs and we can keep them in RAM. Okay, why we are not doing randomly things? Just because actually jobs are of two types. Okay, so jobs are of two types. One is known as CPU bound job, CPU bound job, and the second is IO bound job. CPU bound job and IO bound jobs. CPU bound job means they want CPU more. Okay, they do not want IO devices and so on. They want CPU more. For example, I say CPU extensive jobs, you can think of them as, okay, CPU extensive job which need lot of CPU. They do not want IO devices and so on. So like we are doing very extensive calculations and so on. That these are CPU bound jobs. IO bound jobs, which are, you can say, they need IO more. They do not need, or you can say they need negligible amount of CPU. They are basically IO bound job. For example, we are word processor. You are typing something and that thing is visible on your screen and so on. So these are IO bound job. Like you are taking input from keyboard and output on monitor. We are doing, you can say, negligible amount of calculations and so on. These are IO bound jobs. Okay, so very high or very extensive calculations or those kinds of jobs are CPU bound jobs, and these are IO bound jobs. So think about it. If we have more CPU bound jobs in your RAM, then obviously CPU will never remain idle, that is for sure. But IO devices will remain idle. So it's just like that you will keep on typing something and that will not be visible on your screen because CPU is busy doing CPU bound jobs and so on. So you may think that your computer system is very slow, but actually CPU is doing very extensive hard work and so on. Okay, but you may think that your computer is slow. Similarly, if you have very high number of IO bound jobs and very less CPU bound jobs, then obviously CPU will remain idle. That may create problem. Okay, so the basic idea is we should have a proper job mix. Okay, we should have a proper job mix. Job mix in the sense uh, we should have a proper proportion of CPU bound jobs and IO bound jobs. Okay, so that CPU will never remain idle and IO devices will never remain idle. They will keep on doing something and so on. So everything should be busy. That is the basic idea here. Okay. So that is job scheduling. That's why we are doing job scheduling. Okay. So I have given you answer. Why, after all, why we need job scheduling? Why job scheduling? I have given you answer to this question. Yes. Now let me jump to the next slide. So we have done main memory, CPU, and the third is secondary memory. Okay, main memory is CPU is over, main memory is over, secondary memory. Secondary memory is your you can say hard disk. Okay. Secondary memory can be your hard disk or flash memory. Flash memory, that is pen drive. Okay, CD-ROM, DVD, etc. All these are secondary memory. Okay. So how secondary memory is managed by operating system? In one line, I can say that, see, if you want to create a file in hard disk, do we need to write a program in assembly language to allocate space in hard disk and so on? No. So directly and indirectly, what we mean is OS will provide ease of use. That means OS will see, there are already programs written in operating system which will do all these things for you. Okay, so directly and indirectly, what I can say is assembly language program to allocate memory in hard disk. That program is already in your operating system. Okay, so that program will be called and space will be allocated and so on. Okay, so we can say that uh, in one word, we can say that with the help of operating system, we can access hard disk very easily. Okay, so with OS, we can access secondary memory easily. Easily in the sense we do not need to write programs and so on. Okay, and another thing is OS is also providing security to the hard disk. Okay, OS is also providing security to the hard disk in the sense that uh, see, owner of the file can access that file. If you are not the owner, then you cannot access that. So directly and indirectly, or you cannot edit that file. Okay, so we have some access permissions on the files. All these things are done with the help of operating system only. So it will provide security also. Security to hard disk. That is only owner can access the file. Owner means who has created the file. Owner or creator can access the file and so on. Okay, so the one who is not creator cannot access it. That means the person who is not the owner, they cannot you can say read or write the file and so on. Okay, so this security kind of thing, all these are in multi-user operating system. You can think like that, like Unix. So multiple users are login and they are doing their work. So one user cannot read the file of another user and so on. Okay, that is also done with the help of operating system only. Okay, so it is providing security also. Okay, so now I'm jumping to next slide. Secondary memory, and then we have IO devices. Okay, so the fourth is IO devices. See the slide. Secondary memory is over. Now we are going to study about IO devices. Yes. So how IO devices are managed? So see, there are many IO devices which are attached to your computer system. Like your monitor is an IO device. Monitor is output device. Okay, keyboard is input device. IO means input output devices, na? Keyboard, mouse is input device, okay, joystick, and so on. So there are lots and lots of devices which are attached to your computer system. So enabling, disabling them is done with the help of OS. Enabling, disabling them is done with the help of OS. Is done with the help of OS. Okay. Enabling, disabling means, like for example, if you want to input something, keyboard is enabled. So obviously at that time, mouse and joystick cannot work. Okay, when you are inputting from keyboard, then these will not work parallelly. The word uses parallelly. Okay, why this is so? Actually, you have heard, you have studied these things in operating system also. We have a system bus now. From that system bus, your CPU is connected, your main memory is connected. Okay, and then we have device driver. From that device driver, your secondary memory or your IO devices are attached. Let me say it properly. With device driver, your IO devices are attached. Why we need device drivers and so on? You will study that in computer architecture. I'm not going to explain these things here. Okay, so this is your system bus. So what we want is, if uh, we have another device driver, and from that device driver another IO device is you can say attached and so on. So if one of the IO device is working, then obviously that data will be you can say will be on the system bus. If another device at that time is also enabled, then on system bus there may be collision. So we want to avoid such collisions and so on. So obviously only one of the device will be enabled as input and only one of the device will be enabled as output. All these things are managed by operating system. You can think that way also. Okay. So from now, see, we are using the word automatically done by OS and so on. So nothing is done automatically. Okay. So for each and everything, we have a program. Like for hard disk, we say, okay, we want to provide security and so on. For that also, we have written some programs. Okay. And who have written those programs? Obviously, designer of operating system. Okay. And we can access hard disk easily or secondary memory easily. Why? For example, we do not need to write a program to allocate space in hard disk and so on. That is also, you can say, oh, for that also we have written programs. Okay. So space, allocating space in hard disk, providing security, we have written programs. Job scheduling, so that is also done by job scheduler. Okay, that is also a program which will take some process, and it will take uh, I want to say is what I want to say is from secondary memory, we pick up a process and that process will come in RAM, and then it will be executed and so on. So how these all things will be done? These all things will be done with the help of programs only. So we have written lots and lots of programs. We means designer of operating system. They have written lots and lots of programs. Okay, and here also CPU scheduling, which process will be executed next. This decision is known as process scheduling, or you can say CPU scheduling. Okay, and that is also done with the help of your operating system. So that is also you can say a program. Okay, process scheduler or CPU scheduler, that is a program. Okay, which will take the decision about which process will be executed next and so on. So by now you have got clarity about what exactly is operating system. So roughly, I can say operating system is nothing but it is a huge collection of softwares, okay, programs or softwares, whatever way you want. It is a huge collection of softwares. It is huge collection of software which is used, a huge collection of software which is used to manage all the resources of computer system, which is used to manage all resources of computer system. So that exactly is operating system. It is a huge collection of software which is used to manage all resources of your computer system. So this is a, you can say, rough idea or visualization that what exactly is operating system. So in one word, you can say operating system is nothing but a huge collection of software which is used to manage all resources of computer system. Okay. So I hope I have made the point clear to everybody. Yes. Now let me jump to the next topic. So our first topic, that is definition of operating system, is over. Now we will jump to the second topic, that is interrupt, trap and signal. Okay. Interrupt, trap and signal. So first of all, what is an interrupt? What is an interrupt? So interrupt is an event. Interrupt is an event generated by some IO device to gain attention of CPU. Gain attention of CPU. For example, you are studying. Okay, you are attending my class, and suddenly your phone rings. Okay, your phone bell rings. Then immediately you will say, "Sir, interrupt has occurred," and so on. So, what is the basic meaning of interrupt? Basic meaning of interrupt is you are doing something normally, and immediately someone wants to gain your attention. Why somebody have called you? So to gain your attention, you are doing some other task and someone wants your attention, then they will interrupt you. Okay, so same is the case here. CPU. What is the basic aim of what is the basic task of CPU? To execute the instructions. So CPU is executing some instructions one by one. Actually, CPU is what? CPU is doing, you can say, program execution. More precisely, we should say more precisely. We should say program execution. The basic task of CPU is doing program execution. So that means one by one, it will take the instruction and it will execute it. How instructions are executed? I think you have studied that in computer architecture. Okay, so fetch, decode, execute instruction is fetch, and then it is decode, and then it is executed, and so on. So all these things are done by CPU. Okay, yeah. So and you have studied that also, now how instruction is fetched. It will come from okay, I'm not going into that details because it will hamper our basic flow of your operating system. Actually, that is done in computer architecture. Instruction will come in instruction register, and then a decoder will be activated, and then instruction will be decoded, and then it will be executed, and so on. You have studied that instruction cycle. Try to remember instruction cycle of your computer architecture subject. You will get more clarity. Okay, anyhow, so CPU is executing some instructions one by one. Okay, so now, but one IO device is there. Okay, let me say like this. See, we have a system bus. Actually, operating system and computer architecture subjects are linked. They are very much linked with each other. Okay, so with system bus, we have CPU, and then we have main memory. Okay, and then let us suppose we have a device driver, and with that device driver, hard disk is attached. You already know CPU is very fast and hard disk is very slow. Okay, CPU speed of CPU is in MIPS, million instructions per second. Million means 10 to the power 6 or 10 lakh instructions per second. CPU is that much fast. Okay, but hard disk is very slow. So now if CPU wants some data, it will first go to main memory. Okay, rather we have cache memory also, but I am not going into that details and so on. Let us assume that CPU first, if CPU wants something, then it will first ask main memory. Main memory, if main data is not present in main memory, then hard disk must be accessed. So then CPU will, you can say CPU will try to ask hard disk whether you have data or not. So since hard disk is very slow, so it needs a lot of time to revert back to CPU that I have data or not, and so on. It needs a lot of time. Sorry. Yeah, it needs a lot of time. So what exactly will happen? In that case, CPU will just say hard disk, please give me some data, and then it will resume execution of instructions and so on. It will not wait for hard disk, because if it will keep on waiting, for example, if it wait for 1 millisecond, and I have said 1 million instruction per second, so approximately 10 to the power 6 instructions are executed by CPU per second. So now if CPU has to wait 1 millisecond, then you have got the idea. 10 to the power 3 instructions can be executed in that time. 10 to the power 3 means 1000 instructions can be executed, and CPU has wasted a lot of time. Okay, so better idea is CPU will keep on executing these instructions, and when hard disk is ready with the data, then hard disk will send interrupt to CPU that, see, data is ready, you can come and take it. So that is an example of interrupt. Okay, so hard disk is sending an interrupt to CPU that data is ready, you can come and take it, and so on. Okay, so why hard disk has generated interrupt? To gain attention of CPU. So now see the definition: event generated by IO device to gain attention of CPU. Okay. To gain attention of CPU, this event is generated by some IO devices. These are known as interrupts. Okay, so what after interrupt? Okay, so when interrupt is given to CPU, what will happen? See, take your example. You are attending my class and your phone bell rings. Then you will ignore the phone till I will complete my 1 line or 2 lines. Okay, or the topic which I am doing. You will wait for that so that you can get proper understanding of the topic, and then you will try to attend the phone call. Okay, let us suppose I am jumping to next topic, and then while I am jumping to the next topic, you will check your phone and you will reply the other person and so on. Okay, so the basic idea is you will not see your phone when I am teaching, or you can say when I am doing something. So same is the case with CPU. When CPU is executing current instruction, it will not check for interrupt and so on. Okay, so when instruction execution is completed, then after that CPU will check which device has generated interrupt and why, with the help of operating system. Okay, let me jump to the next slide and I will show you the things. See, if you have a little bit idea, instruction fetch, instruction decode, and then execute. Roughly I'm saying. Okay, and then it will check interrupt has occurred or not. If some interrupt is there, then it will try to see, CPU will try to see which device has generated interrupt and why. Okay, and then it will try to handle that. Okay, so these are this is a instruction cycle, instruction fetch, decode, execute, and then interrupt. If there is no interrupt, then it will fetch a next instruction and then decode it, then execute, and so on. But if there is an interrupt, okay, then what it will done, it will first check which devices has generated interrupt and why with the help of operating system. And once it get to know about, okay, hard disk has generated interrupt because it has data to it has data is ready and I can take it. CPU has got the idea. Then it will execute another program that is known as ISR, or interrupt service routine. Okay. So as soon as CPU know that which device has generated interrupt and why with the help of operating system, then it will run a new program called ISR, or interrupt service routine, to handle that interrupt. ISR to handle that interrupt. To handle that interrupt. Okay, whatever interrupt is there, to handle that interrupt, it will run a ISR. Okay. So actually you have got it that there are multiple reasons of generating interrupt by multiple devices. So for each and every reason, there is an ISR, or interrupt service routine. Okay, so interrupt service routine, what it will do? It will take the data from hard disk. Okay, actually device driver is just like a buffer. It will store the data which has been taken from the hard disk, and then from this device driver, or you can say buffer, this data will be transferred to CPU registers, and then that data will be executed and so on. So all these things are done with the help of interrupt service routine. Okay, so I hope I have made the point clear. I'm just telling you, I'm just giving you a very small hint. I'm not going into details and so on. So number of interrupts, that is equal to number of interrupt service routines. Okay, number of ISR, that is equal to number of possible interrupts. Okay, let me write it. So number of ISR, interrupt service routine, that is equal to number of interrupts. Okay, yes. So I hope I have made the point clear. So obviously, designer of operating system must first think about all the possible types of interrupts, and then it will write a program, or you can say called interrupt service routine, to handle each of them. Okay, so first he has to think about how many types of interrupts are possible, and then for each and every interrupt, it will write one ISR, or you can say interrupt service routine, and so on, to handle interrupts. Okay, so I hope I have made the point clear to everyone. Okay, and one more point I want to say is, after after execution of ISR, or you can say interrupt service routine, CPU will again start the normal program execution. Like CPU is executing this program, and here interrupt comes, and then it will go and execute ISR, and then when it comes back, it has to resume from the same point where it has left. So how it will come to know about all these things? So directly and indirectly, I will say that state of the, you can say, process or state of the program must be saved before transferring the control to ISR, or interrupt service routine. Okay, so state of process must be saved. So for example, all the register values and so on, those must be saved, and then you can say ISR will be executed, and then when it is resumed, when program execution is resumed again, then from that state it will come to know, okay, I have to start from here, and so on. Okay, I'm just giving you small idea, that's it. I'm not going into detail and so on. Okay, yes, so that's it. So this is all about your interrupts. Next is trap. Let me jump to the next slide. Trap. What is a trap? See, trap is an event generated by CPU. It is an event generated by CPU. And why it has generated it? Event generated by CPU to stop program under execution. To stop program under execution. So you may think that, sir, why we need to stop that program and so on? See, we need a CPU need to stop a program when something illegal has happened. something illegal. Illegal in the sense, roughly I'm saying, for example, let me say it properly. Okay, illegal here means some exception or runtime error has occurred. Some exception or runtime error has occurred. Runtime error has occurred. Okay, so for example, divide by 0. Okay, you are dividing to, a by b, and you are dividing a by b. Okay, and we have supplied b is equal to 0. So that is an example of runtime error. Okay, so if you have written exceptional handling code and so on in any programming language, then that thing will be done. Otherwise, that you can say program will stop execution. And how it will be stopped? With the help of trap only. Okay, so trap is an event generated by CPU to stop program under execution. Okay, and another idea is, say for example, this is your main memory. Okay, and let us suppose see actually actually every process has a process address space. Process address space. So process address space is the area which is area of main memory which is allocated to the process. For example, I can say that from 2000 location to 3999. That means 2000 bytes of main memory is allocated to any process, say P1. Okay, and in that process, okay, some statement is like jump 5000. So that means what? This you can say from process P1 we want to jump to a location which it does not own. Okay, and this is not allowed. Okay, OS will not allow such kind of things, because if one process will try to access memory of another process, then obviously everything will become messy, na? That's why OS will not allow these kind of things. So each and every process has a process address space, and it's a restriction that process must you can say this is the area of process. Okay, and it cannot cross it. Once it try to cross it, immediately that process will be stopped, or that program will be, or process means what, roughly you can say program under execution. So that will be immediately stopped by operating system itself. So these are few reasons that why trap will be generated. Okay, so whenever process goes out of its process address space, okay, or divide by 0 and so on, any runtime error or any exception occurs, trap will be generated by CPU to stop the program under execution. That is a small idea. Okay, so obviously how program will be stopped? There is nothing called automatically. Okay, we have to write program for each and everything. Similarly, for each and every trap, we have trap service routine. Okay. So designer of OS has to think about what are the various reasons of generating trap and so on. So for each of that, we have to write a program called TSR, or trap service routine. Okay, so the basic difference between TSR and ISR. TSR and ISR will be that in case of ISR, state of process must be saved, so that when we come back, or when CPU come back after executing of ISR, it can resume it. But in case of TSR, state of process should not be saved. Why? Because anyhow we are just killing that process. Now we are just stopping that. So why we need to resume it? Obviously. Okay. So state of process is not saved before starting execution of TSR, and before starting execution of ISR, state of process must be saved. Okay? Yes. So I hope I have made the point clear to everybody. That is the basic difference between TSR and ISR. Okay. Yes. So, and one of the very beautiful question that has been asked in GATE. So, what do you think? Which is asynchronous and which is synchronous with respect to program execution? So, I want to say, can you tell me that interrupts are, if I say interrupts are asynchronous with respect to program execution? This has been asked in GATE exam. With respect to program execution, is it true or false? Interrupts are asynchronous with respect to program execution. Yes, 100% the statement is true. Why? Asynchronous means we do not know, or we cannot predict when interrupt will come. For example, I show you a program. Can you tell me by reading the lines of the program where interrupt will come? No. I do not know when hard disk will generate interrupt and so on. Okay, so obviously these are asynchronous activity. I am teaching you and your phone bell will ring. So can you predict when your phone bell will ring? No, I cannot predict those things. Obviously, interrupts are asynchronous with respect to program execution. Okay, and what about my traps? What about my traps? So traps are synchronous with respect to program execution. Why? Because by seeing the program, we can predict there are some chances of trap and so on. As soon as you see like A by B and B, you can supply 0. So you can say that, okay, there are some chances that here we can have a trap and so on. Okay. Yes. So I hope I have made the point clear. So traps are synchronous with respect to program execution, but interrupts are asynchronous with respect to program execution. Okay. So next definition is signal. Next definition is signal. So what is a signal? Signal is an event generated by user. These are very, very important points. Okay. Event generated by user. Event generated by user or program under execution. Or program under execution. So these signal terms is basically come from Unix operating system. So we have different kind of signal and so on. So signal is event generated by user for program under execution. Okay. So for example, if we type Control C, so process will be killed. I'm just giving you some examples. Okay. Control D, so end of line, and so on. Okay. So there are lots and lots of signals. So Control C is written like this. See, like this. That is used to kill the process, or you can say kill the program under execution. Okay, and so on. Okay, yes. So Control Z, we can have Control Z. If a process is running in the foreground and we want to, you can say suspend it. Okay, so suspend it, or you can say running in background. And so there are actually lots and lots of signals. I'm not going into that much detail because that is not required for your GATE exam or any competitive exam. So I'm just giving you an idea, or you can say a hint. Okay, that's it. Okay, so these are some example of signals. Okay, so if you have studied Unix operating system, you have got the idea what exactly are signals and so on. So these are the events generated by user for the program under execution. Okay, so okay, and we want to, and why we are generating those events? Like we want to kill the process, or we want to suspend that process and so on. For these kind of thing we are doing. Okay, so similar to ISR TSR, we have signal service routine, SSR, signal service routine. Okay, to handle that signal. To handle that signal, we have signal service routine. Okay, so I hope I have made the point clear to everybody. Yes. So in the summary, what I can say, let me jump to the next slide. So interrupt, trap, and signal. Interrupt generated. Who is generating interrupt? Your IO devices. Who is generating trap? CPU. Who is generating signal? User. Okay. And for whom? Interrupt is for to gain attention of CPU. Trap is for you can say kill the program under execution, and signal is for program under execution only. Okay. So PUE. I'm writing roughly. Okay. Program under execution. And trap is specifically used to kill the program under execution, and signal may be also used to kill the program and so on. Okay, anyhow, I'm not going into detail of all these things and so on, so I'm just giving you idea. Interrupt is an event generated by IO device for CPU. Trap is an event generated by CPU to kill the program under execution. Signal is an event generated by user for program under execution. So CPU is involved in interrupt as well as trap. CPU is involved, but in case of signal, CPU is not involved. So you are just sending some event to the program under execution and so on. Roughly, you can think of it like that. Okay, so that's it. So this is all about your second topic, that is interrupt, trap, and signal. Okay, and see the topics. Okay, let me jump to the slide. So in today's class, we have done definition of operating system, and the second is interrupt, trap, and signal. Okay, next is protection and then types of OS. These two topics we will cover in the next lecture. Okay, yes, so you can note down all these things and then I will over the lecture. Yes, thank you so much. Bye bye.